All right, welcome back to another episode of the Legal Lowdown. I'm your host, Matthew R. Carpenter, an attorney, and today's topic is quantum computers. Honestly, it's something that sounds low key like it's straight out of some sci fi movie, but trust me, quantum computers aren't science fiction anymore. The technology is here, and it's really poised to change, well, absolutely everything. Our mission today is simple: unpack this mind bending technology, show you exactly why it matters to your pockets, your opportunities, yes, your future even. And we're going to discuss both the incredible benefits and the serious risk already knocking on our door. Let's get into it. It's kind of crazy how something so revolutionary is still so misunderstood and under the radar. For most folks, this podcast is really about pulling back that curtain, right? Giving you the real deal so you understand not just what quantum computing is, but maybe more importantly, why you absolutely need to be paying attention to it. Okay, so first things first, let's talk about the sheer power we're looking at here. I mean, the potential is frankly jaw-dropping. We're talking about a technology that researchers firmly believe can tackle some of nature's and humanity's toughest problems, the ones that have stuck around forever. Just imagine this for a second: curing cancer, unlocking unlimited clean energy from nuclear fusion. Yeah, that's actually on the table. Maybe even making interstellar space travel safe, feasible, possible, right? And look, these aren't just some far-off pipe dreams. This is the future that's actively being built right now. And the US government, they're not just watching. They're putting big money into quantum research to make this stuff happen. And if you zoom out a bit, the core of this is really about solving these monumental challenges, the ones that have stumped us for generations. Think about the implications for global health, for the planet itself, for, humanity reaching beyond where we are now, which brings us to a pretty crucial question. If the potential is so big with quantum computing, why isn't everyone talking about it? Why isn't it front page news everywhere? The answer? Most people simply just don't understand it. Some folks, they don't even believe it's real. They think it's just, Hollywood stuff. Even the experts, the people deep in the field, they admit it's genuinely tough to explain. And believe me, as someone who's read a ton of articles and listened to a lot of public speaking on this topic, it is hard for them to explain, but I'm going to try to help you with that. The confusion, that's exactly where opportunity lies. This lack of awareness, that gap, that could be a massive untapped advantage for those of us who do take the time to figure this stuff out. This isn't about being complicated just to be complicated. It's a paradigm shift in how we compute, how we solve things, and recognizing that gap in public knowledge, that's where big bucks can be made. Okay, so let's talk proof then. We need some proof after all that hype, right? Well, just last year, Google made a huge splash by developing a quantum computing chip called Willow. It's tiny, I mean really tiny, no bigger than a cracker. But that tiny chip is a powerhouse. It solved the complex algorithm in just 5 minutes. I know that sounds basic, but walk with me. The world's most advanced classical supercomputers, they would have taken 10 septillion years to solve the same problem. That amount of time, it's hard to even comprehend. Let that sink in. It's 10 septillion years. But it's not maybe, that's not someday. That's publicly reported fact, a real world demo. Now think about it. Our entire universe, it's only about 14 billion years old, right? Billion versus septillion. So for something to solve a problem in minutes that takes other computers literally septillions of years, that doesn't just push tech boundaries. It fundamentally challenges how we even think about time, how we understand reality itself. Physicists like David Deutsch, who's a professor at the University of Oxford, one of the best universities in the world, he theorizes that quantum computers get their speed by channeling data from multiple universes through a concept called superposition. It's wild stuff, and the sheer increase in processing power that quantum computers offer is forcing us to question our basic understanding of reality. It's not just faster, it's not just more, it's fundamentally different, a different way of processing information, which brings us right back to that question. How does something so tiny pull off such an incredible feat? The answer lies deep in how quantum mechanics actually work. So let's unpack that science for a second. Think about our everyday computers, right? Your phone, your laptop. Those are classical computers. They run on transistors, semiconductor chips. Those chips basically allow your computer to speak in binary ones and zeros, yes or no's, on or off. Limited states like that, one or the other. With binary language and processing, your computer is really just working through a series of yes or no questions to address the problems or tasks you put into it. But what if you could throw in a maybe or possibly, or even both at the same time? Now you're talking quantum. That's exactly where quantum computers step in, actually. Instead of that limited binary process offered by semiconductors, quantum computers use calculations that run on subatomic particles, things like atoms, electrons, photons. And that's the game changer. Like, they literally are creating computers that are replacing chips with these subatomic particles. And these tiny particles play by very different rules. They open up a whole new world of processing power. Quantum rules. They defy classical logic. Thanks to the laws of physics that apply to subatomic particles, quantum computers aren't just thinking in zeros and ones. They can consider anything in between, even multiple variables at the same time. So let me explain. I know this is a little bit difficult to follow, but this experiment really helps put things in perspective. There's a famous experiment called the double slit experiment. German physicist Klaus Johnson did the key work in that one. Basically, he shot a particle, one particle, say an electron, at a wall with two slits in it. Classically, you'd think this solid object, the electron, would go through either one slit or the other. That makes sense, right? But what actually happened is that the single electron went through both slits at the same time, simultaneously. In short, the double slit experiment proves subatomic particles like electrons can travel multiple paths at once. Sounds crazy, defies common sense even, but it's a scientifically verified fact. And that's the core idea. Quantum computers harness the incredible ability of these particles. That is, in other words, to be in multiple states at once. That's superposition. And that's happening inside a quantum computer. It allows for calculations that are just exponentially more complex than anything a classical computer could ever dream of handling. So connecting this back to the bigger picture, it means that these machines can process information with so much more nuance, so much more power. It's beyond anything we've seen. It's not just speed. Remember, it's the ability to model incredibly complex systems where tons of possibilities exist all at once. And that fundamentally opens doors to solving problems we previously thought were just impossible, unsolvable. And look, this isn't just high-minded theory anymore, y'all. This is real with quantum computers. The possibilities, they really feel limitless. It's a paradigm shift across so many industries, but you know how it goes. With great power comes great responsibility and even greater risk. There's always a flip side. And that's precisely where the critical implications kick in. Yes, the applications for good are immense and world-changing, but it forces us to confront what really might happen if this incredible power falls into the wrong hands. One of the biggest concerns, the one keeping security experts up at night, is encryption, the backbone of digital security. Encryption, that's the digital lock and key protecting all your sensitive data. Governments, big corporations, your personal bank account, everything. Classical computers, they take millions of years to crack today's advanced encryptions. So our data feels safe, theoretically for now anyway. But that landscape, that encryption landscape, it's changing incredibly fast. There are reports, claims even, from Chinese researchers saying that they can already crack the advanced encryption standard, which, as the name implies, is the most advanced encryption standard that we have today. It's called AES. They say they cracked it using a D-Wave quantum computer in minutes. Whether those specific claims are fully verified or not, the threat is real regardless and widely acknowledged. It's just the timeline that is debated and the implications. Honestly, it's kind of terrifying. Enemy states, rogue actors hacking into critical nuclear systems, taking down power grids, stealing top secret intelligence. In the wrong hands, quantum computing could fundamentally shift the balance of power globally. An ability like that could put one nation, one group in a position to dominate the world. And what's really striking, though, is that stark dual-use nature, right? The very same power that holds the promise of cures and clean energy can also be weaponized to destabilize finance, to compromise national security. It's precisely that reality, that sharp edge, that has the governments worldwide taking quantum computing very seriously. This isn't just some science project anymore. It's a strategic imperative, a global race, if you will. So, okay, with all that on the table, what's our government doing? How are we trying to keep people safe, stay ahead of the curve? Uncle Sam can't just be sitting back, right? No, he's been making some significant moves trying to get ahead of this. Proactive steps are crucial here. So back in 2018, we saw the launch of the National Quantum Initiative, the NQI. That law boosted federal funding for quantum research across computing, economics, and national security. The clear goal? Keeping the U.S. ahead in quantum computing and quantum tech fields. Maintaining that edge is vital. Remember those Chinese hacking encryption claims we talked about? That was a major wake-up call. It spurred NIST, the National Institute of Standards and Technology, to push forward with post-quantum encryption standards. This is all about developing brand new encryption, new algorithms designed specifically to resist attacks from powerful quantum computers. Building quantum-resistant locks, basically future-proofing our digital infrastructure. If quantum is fake, why are we doing this? It's essential. And most recently, just last year, 2024, the U.S. Commerce Department stepped in. They imposed export controls on quantum computing. They classified quantum tech officially as a critical technology, y'all. That's a crazy designation because it means for businesses, investors, or innovators that selling or even transferring certain quantum components now needs federal approval. Yeah. So if you're thinking about investing or developing something in this space, you have to know about these regulations because they're real. So in summary, how do we connect all these actions to the broader picture? To me, they underscore the profound strategic importance of quantum. It's way more than just a scientific race. It's fundamental to economic competitiveness, to technological leadership, and to national security. It shows the U.S. isn't just waiting for a crisis, it's actively trying to shape the future of this technology, making sure its power is used for good and protected from, those who misuse it. Okay, now let's shift gears a bit. Let's talk quickly about money before I wrap this all up. Because beyond all this mind-bending science, quantum computers are rapidly turning into modern-day rainmakers, creating some serious wealth, and I want you all to be aware of it. You gotta listen to this. So in just the last year, shares of one company, Quantum Computing Inc., the NASDAQ ticker for that one is QUBT, those shares skyrocketed a staggering 1,600%, 1,600% increase in 365 days. We're talking a jump from like 70 cents a share to $15. And why? What was the trigger? NASA. It invested heavily in their Direct3 computer. That's a massive signal, right? A huge vote of confidence and market reaction that sends the silent nod to these quantum tech companies. And Qubit, or Quantum Computing Inc., wasn't just a one-off. The same kind of thing happened with another quantum computing tech stock, Ionic, IONQ. Their stock soared from around $7 to $40 a share. That's incredible growth. So there's real momentum here. This isn't just some fleeting tech trend on the bubble. It looks like a serious, proven investment opportunity with tangible real-world returns happening now. Even back in 2020, quantum computing was already ranked as one of the top 10 fastest-growing tech sectors. It had something like a 41.75% compound annual growth rate predicted. That's undeniable value being generated right now, which a lot of people don't even know about. And that brings us back to the crucial question for you listening. In this world where we're just saturated with information, where these truly transformative opportunities can often be hidden in plain sight, how do you position yourself? How do you get ready, not just to understand these huge shifts like quantum tech, but to potentially benefit from them, to be, maybe an early adopter in this future that's unfolding before it's too late, like crypto, for example. So what's the real deal here? What's the bottom line? Quantum computing. It's not fantasy anymore. It's not lurking in some distant future in some sci-fi novel. It's here. It's developing at breakneck speed, and much like the internet was decades ago, it promises to be one of the most revolutionary developments in human history. How will it change our lives next in ways we probably can't even imagine right now? That's a conversation maybe for another time. Well, that's all I got for you today for this Legal Lowdown. Stay sharp, folks. Stay informed, and we'll catch you in the next episode. Thank you for listening. Peace.